Now good? Okay. For anybody in the hall eating lunch, we're about to start. I don't know if they care. Sure, no problem. Hey everybody, my name is Matthew Gusdile. I will be a guest lecturer as part of this, invited speaker, whatever term you want to use for this. For the next little bit, we'll be doing 2 sessions today on introduction to Unity and then talking about game design frameworks and paper prototyping. And then tomorrow in the morning, I guess in the morning, I don't actually know. Somebody could check the schedule and tell me when. I'm going to be doing a talk on the basics of game AI. With that, I've got a really brief set of slides, which I'm probably not even going to present. I'm just going to click through, just sort of guide the beginning here. And then this is going to be a really hands-on working with Unity thing. So if you don't already have Unity on whatever computer is in front of you, I would get it as soon as possible, or at least try to open it up. Ideally, this will be very interactive, and there'll be a lot of back and forth, but we'll see how this goes. I saw, at least in the morning session, that, oh, I shouldn't move around so much. I understand now. That maybe you all are a little bit on the quiet side, but I'll do my best to engage you and get you to speak to me. So who am I? Why should you be listening to me at all? So my name is Matthew Gusdile. As I mentioned, that's me, but in a different shirt and with a different haircut, in case you were confused. I did some work at Zynga and then EA Sports, and then I said, I'm done with this games industry thing, and I went to get my PhD at Georgia Tech, which is in the States. I'm from the States, sorry. Sorry, Surrey. There we go, got it at that time. And then I did some work with Unity and Disney Research. That's why I have a Unity water bottle, in case anybody is curious about that. I'm not a Unity shill, even though I'm teaching you Unity today. Don't get it twisted. These days, I'm at the University of Alberta and also a Canada CFAR AI chair at AIME, where I do research at the intersection of games and artificial intelligence. If you want to talk to me about any of those things, I'd be more than happy to talk to you about them in a bit. But for today, we'll talk about Unity. So I think that actually Gavin already did this for me. My first thing I was going to do is just ask who has experience with Unity, which a few people raised their hands, but I think there have been a few new people. So can I just get a show of hands who has used Unity before? Okay, 4 or 5 of you. Who has opened Unity before? A bunch more of you. Okay, all right, cool. So that's good. So there's at least some familiarity with Unity. So step 1 to be able to use Unity is you have to download Unity. I know, this is a big surprise. I'm going to talk you through this a little bit. We're going to open this. Oh, I was hoping that would just click, but it didn't. That's fine. We'll just do that. And you can see here, this is just the default Unity site. Of course, they want me to give me cookies. Don't let them. And there's some options here in terms of downloading Unity hubs. You'll need to do that. You'll need to choose your Unity version, et cetera, et cetera. Notably, when you are attempting to download a version of Unity, they're going to try to get you to do buying a version, or at least an educational version, because they're trying to get you, hooked into it. A personal Unity version is more than sufficient. You don't need anything else. If you want to go for the education version because it has a few extra bells and whistles, you certainly can. It's just that you lose it once you are no longer a student. So the first thing you're going to have to do regardless is download Unity Hub. This is Unity Hub. Well, yours isn't going to look like that because you don't have these projects, but otherwise it will be the same. Unity Hub is basically, as Gavin was gesturing at, a way of handling all of your projects and all your different Unity versions in one convenient little thing. And it also is ensuring that you have the Unity licenses that they want you to have. So once you have a version of Unity, or the Unity Hub, you can install particular official versions. You can see here official releases. If you want to go for pre-releases, you certainly can, etc. There's also a Learn tab here. I don't think they're particularly good, these tutorials, but you can certainly go for them. They might be useful. And there's a Community tab, which is sort of like forums and things like that. Those are not super relevant. Once you have Unity installed, or Unity Hub installed, you now need to download a particular version of Unity. I think that the 2019 was the most stable version of Unity that has so far existed. There was also an okay version in 2022, but I don't recommend going for the most updated releases. Unity as a company, as you might have heard of with the whole thing about them trying to like get people to pay for installs and things like that, is in a spot where they desperately need additional equity because of dumb shareholder reasons. And so because of that, they're making lots of silly decisions like not supporting their base engine. So there's some versions, thankfully, that you can still download that Unity still hosts that are perfectly good, but I don't recommend the most recent ones. From there, you need to launch Unity and then open up a new project, which is what we're going to be doing right now. So I'm going to go back to our Unity Hub. If you have downloaded Unity Hub, but you don't have a Unity project, it's going to prompt you to grab one of those. But I'm going to go ahead and hit New Project. Once you hit that, you'll see at the top middle of my screen, we have a version that we need to select. Yes, at this point, you should have Unity Hub open. If you haven't already had Unity Hub open, open Unity Hub so you can follow along. Or if you just want to watch, I guess, you can just watch, but I was hoping more interactive. Yeah. So there's no reason not to. Go search Unity Hub on the lab computer in front of you, find it, open it up. It is going to make you sign up for a license of some sort if you want to prompt it, but it's easy to sign up for a personal license. You can, again, also sign up for an education license. So I'll give just a second and drink some water while I hopefully wait for everybody to sign in and get Unity open. Yeah, what's up? So once you've got a thing, so you've got 2022 there. 2022 is perfectly fine. You can just do the 2022 install. That's fine.
Or even the 20.
I don't recommend the 2021 install. 2022 is fine. 2022 and 2019, those were good Unity of years. It's like with wine, except what if the wine had particularly horrible years very recently? So once you've got that installed, you should be able to get that open. Hopefully everybody can follow along at this sort of rate. I'm looking up, I'm seeing dark gray boxes. That's a good sign. Dark gray, good, good, good. We're doing well. Sorry for anybody watching on the stream who isn't seeing my face. I do apologize. You'll see my face again in just a moment. This is all looking all right. Okay. I'm gonna go ahead and keep moving just to keep things moving along. So the next thing that we'll have to decide, we'll have to actually pick a version if you want to select a particular version. You see here I have one 2022, two 2019s, and a 2018, which gives you a sense of where I think the good bits of Unity live. I'll do a 2022 because it's probably the version that you all will most easily be able to install. So let's keep it on 2022. And from there, we'll need to pick a Unity kind of project. You'll note here we have a lot of options. We have a 2D built-in render pipeline, a 3D built-in render pipeline, universal 2D, universal 3D, high definition 3D, universal 3D sample, high definition 3D sample, etc., etc., etc. It goes on and on and on. You'll note you'd have to install other things. That's what this little cloud with a down arrow means. So we're basically stuck with these top three. It really doesn't actually matter. This choice is functionally does not matter at all because you can go back and forth between any of these different sort of components that it would give you in any version. It doesn't matter. But we're going to go ahead with that middle one, the 3D built-in render pipeline. That's the one we're going to go with. And I'm just going to name this something obvious so that I can refer to it. This will be Kamloop's example. And I'll try to send this to Gavin or Joseph, and maybe they can put it somewhere where you can grab it if you want it. Sure. Yeah. That totally works. Okay, so once you hit the launch or the create, it'll take it a little bit. It's thinking, it's rendering, it's installing a whole bunch of libraries that you don't actually need for this project, but it's going to do it anyway. That's what this is. Hopefully everybody can hit this point. If you can't, raise a hand or something, and while I'm waiting, I can certainly help. Yeah, what's up? Yeah, so install editor. See details. Let's hit see details on the 2022 one, this one. Install failed, validation failed. So it looks like it was trying to install it, but it wasn't able to. I'd hit that X, or actually hit the retry. Let's try the retry, the download. Oh, it failed again. Okay. Oh. Well, that would be problematic. Does that mean that we won't be able to have anybody open Unity?
I think that 22. So
It looks like Unity Hub got installed, but no Unity versions got installed. Yeah. Okay, you have a 2023 version? Okay. Well, it doesn't really matter. So if need be, just go to your projects and let's hit new project and let's just see. Oh no, it's gonna make you try to. Okay, let's try 2021. Okay, continue. Yeah, we agree. We of course agree to your terms of service. Please, Unity. Okay, so the 2021 seems like it'll install maybe on these computers, even if 2022 won't. So just get any version of Unity installed. I was being particular, but on your own device, maybe try to get like a 2019 or a 2022 version. But for these lab computers, who cares what version they have, right? Just get something so that you can launch a project. Once you're at this step, that looks great, Jose. Hit create project once you've given that a name that you can recognize. And you should have a loading bar. Perfect. Looks good. Yeah, what's up? The middle one. You got the right one. So you can just hit the create project now. You're good to go. It seems like some of the computers have a Unity install on them and some of them don't. So you might try and go to hop to a different PC. That looks good. That looks fine. That looks good. Oh, you already got like scripting editors open. Phenomenal. It doesn't matter. It doesn't matter. These are just lab computers. Any version of Unity will work. It all has the same basic components. There's just some really weird particular bugs that they introduced in more recent versions, and then they squashed them in like 2022. Those were got better. But in 2023, they're back. And so if you're trying to do particular things, you might run into problems. But it'll be fine for this example. Okay. All right, I think that at least the majority of us are here. If need be, when I hit my next sort of stopping point, you're stuck, I can come back and help around, walk around. But let's take a look. So your sort of layout might look a little bit different. I'm going to full screen this. There we go. I'm going to have to unfull screen in a second, but we'll get there when I get there. Your layout might look a little bit different than mine. This is my preferred layout. This doesn't have to be your preferred layout. If you go up to Window and then Layouts, you'll see that I have 2x3, which looks like this. And then I get rid of this window, this little column here, because nobody needs it. And then that looks like that. That's the version that I'm going to be using for the purposes of this example. Other people use different things. I like it because I can see all the different components really easily, which is nice. But it's up to you. So I'm going to talk through this screen to begin with, and I'm going to walk over here. Sorry for the people on the Zoom, but you can still hear my voice, and you can still see my screen, so that's all that matters. On the top left there, you can see that you have the scene view. So those of you who've already used Unity will already know what this is, but those of you who haven't, this is basically what's actually truly going on in the virtual space of your game. If you can't get Unity to install, I would just go to a different PC. I don't think it's worth trying to like get the install to work. On the bottom left, we have the game view. This is unsurprisingly what a player of the game would actually see if they were to run your game right now. By default, it should look something like this, where it's just sort of like an endless horizon sort of thing. I'll be back over there in a second. I can adjust that myself if it's helpful. In the middle here, you'll see we have something called sample scene up at the top. So this right here is the sort of the scene hierarchy. So these are all the objects that are in the scene. You'll note there's a little like arrow. It might be hard to see, especially because there's lights on in this room. But if we click down on this little arrow right here, we can see that we have two things. There we go. Now that you're slightly uneven. There we go. I'm my own cameraman. Look at that. You can see I have two things in the scene. Nice. Thank you, Joseph. We have a main camera and we have a directional light, right? So the main camera is a virtual camera. It's going to be telling us what the game should be rendering, right? Frame by frame. The directional light, unsurprisingly, is a directional light. It's a virtual lighting system, right? The final thing that we have, if we look over here, is our project view. In our project view, we have all these packages that Unity forces you to install when you open one of these versions. Oh, it didn't actually install on me. That's nice. And then we have a scene as our only thing that's in our assets. This is basically like the memory of the game. Like if this was on a disk, for example, this sort of project view would be everything that was stored on the disk. Does that make sense? So that's it. That's the sort of basic components of this. There's also another window you can see on the far right there, the inspector view. We're going to take a look at that right now. So if you actually click on the main camera object, you should be able to click on that there, and you should see that it opens up in the inspector view. In the inspector view, then, we can see that we have several components on this game object. Everything in Unity is game object based. That means that there's basically a virtual thing, which just represents what this thing is. It's a little bit vague, but basically any noun in a game would be a game object, right? So a camera is, of course, also a game object, right? Game objects are only differentiated to other game objects by what components they have on themselves. So every game object will have this top little bit here. You can see we have a name, and then we have a transform with position, rotation, and scale, right? People know what position, rotation, and scale is? Some nods or shows of hands. Is anybody confused by what position, rotation, and scale would mean? Is anybody embarrassed to say that they're confused by what position, rotation, and scale would mean? Okay, so nodding. Okay, we'll get to that in just a second. I'll give you an example of what position, rotation, and scale mean. Then we have two components down here. And again, game objects are only differentiated by components in Unity. So whatever components are on it. So this, you'll see the next one, we have a camera component. This means that we could put this camera component on any game object, right? If we wanted to. We just get one by default for free in this environment, just to start with. The camera component, as like every component that's built into Unity, has several different sort of options in here. You'll see that we have a skybox, right? Do people know what a skybox is? Show of hands. Who knows what a skybox is? Okay, about half the room. Let me explain. If you've ever clipped out of a game, if somebody clipped out of a game and they've just seen like what looks like an endless sky or ocean, right? The game isn't actually an endless sky or ocean. What they have is a skybox, which is basically as far back as they can get. If there's nothing else to render, they're going to render a sort of texture, a round texture to represent like the sky. Make sense? So that's what that is. So that's an option for our game. We could also pick like solid color, and then look how that changes things, right? I just changed skybox to solid color, and immediately in my camera view, which is the game view, right? It now looks like I just have like a dark blue scene, right? But if we look in the scene view, we can see nothing has changed. Does that make sense? The scene view is the truth. It's the actual thing that's happening. The game view is the lies that we're going to put in front of the player. Cool? I'm going to swap back to the skybox because it looks a little bit better. Don't really have to worry about the other two. There's a culling mark here, which is culling mask, which is basically what are we not going to render. A virtual camera is basically a decision of what are we rendering or not. Rendering meaning what's actually going to be on the screen, right? And this is just a basic way of saying anything that's past a certain point, we're just going to cull. The projection is sort of how are we going to view the scene. So this is using this sort of perspective projection, which is a sort of 3D projection. So things that are further away are going to look smaller, right? It's like how your human eyes work. If instead we wanted everything to look flat, so it all just looked like it was stacked on top of each other, we could instead change this from perspective to orthographic. You'll see that there's the game scene doesn't really change, the game view doesn't really change, but we can see on the camera view here that it's changed from a sort of prism, like a triangle sort of thing, to just a big rectangle. And that's to say that everything is just going to be viewed as if you're like looking at it with one eye, right? So just everything looks like the size that it is, basically. And that's useful for like 2D games, but we're in a 3D space, so we're going to use that. There's a lot of other things in here. We mostly are not going to have to deal with this. If you wanted to do clever things with like what's going to clip, so what's not going to be shown to the camera, what's not going to be rendered, you might have to deal with these other things. But generally speaking, if all you're thinking about is like, well, do I need my camera to be for 3D or 2D, you only really need to be thinking about these top things. You only really need to be thinking about what's the skybox, and what's the culling mask, and what's the projection. Cool? Okay, so that's giving us cameras. And we also have this directional light. I'm not going to talk about this in detail, but it works very much like how you would expect a directional light to work. There's all of these sort of parameters on it, all these little like toggleable things, just as like the camera. You can look at this as if you like, and if you'd like to get into lighting, it can be useful, but we're generally not going to focus on that right now. Okay, so this is a very simple sample scene. It's just the default that we get with Unity. Now, though, we want to actually add things to it. As I suggested, adding things is about adding game objects. So the only thing that matters is, again, what components we have on those game objects. Yeah? Oh, I'm about to do that with this. It's going to be much easier to see when it's something that isn't the camera. I appreciate the reminder. So we're going to go into components, and then I want to go on down, oh, sorry, not components, game objects. We'll go on down to 3D objects. It's our kind of game object we're going to make. And let's just make a cube, because that should be very clear. So just to be clear, I'm going to do that again. I went to game object, I went to 3D objects, I went to cube. Whoop. Now I have 2 cubes. I'm going to delete one of these because I don't need one of them. If I right click, I can delete it, no problem. And there's our cube. So there's our very simple little cube that we've now added into our scene. And with this, I can now explain more about how sort of the 3D stuff works in Unity. So note, if we look at it from the top left view, right, that's the scene view. Again, that's the ground truth. But we're still looking into the ground truth from a certain perspective because we're humans and we're limited. Oh, isn't that beautiful? And so because of that, we can sort of see this cube from this one perspective. If we look down here, right, at the game view, we can instead see the cube looking at it face on, which means that it looks basically like a square. Because I don't know if you knew this about cubes, but it's just several squares all together. You ever seen a dice? Or a die? I'm sorry. Over here on the right, we can see that we have several components we haven't seen before. So we have the transform, and we'll get it to the transform in a second in terms of the position, rotation, and scale. We also have a cube mesh. So this is the mesh that's telling it what this object should look like. Okay? That's in terms of what's the 3D object going to look like. If I wanted to, I could replace the mesh on here so it's no longer a cube. So for example, if I make it none, nothing's going to show up. Voila, I've made a cube disappear. Take that, all magicians. But I could change it out to a capsule, to a cylinder, to a plane, to a sphere, etc. These are all the default 3D objects that are just built into Unity. If you wanted to import a new 3D object, a new 3D model, it would come with its own mesh, and then you could replace that, for example. Make sense? But we're going to stick it with a cube, because I think that makes the most sense for this example. There's also a mesh renderer. I know this might be a little bit confusing, but this is 2 different pieces of information. The 3D mesh is telling us what should the object, the structure of the object be. The mesh renderer is saying, how are we looking at that object? What does that object look like on screen, right? So I can change my mesh renderer by, for example, changing out like the materials on here. You can see right now there's just a default material. If I wanted to, I could make a new material. Easiest way to do that would be to go to Assets. You can right-click and then go to Create, or you can hit this big plus up here, and that will also give you the same thing. And then you can go on down to Material. We can make a new material. I'll call this like Cube Material, right? So then I could change this out. There's lots of options on here. We don't really need to get into it. We can just keep it opaque, but let's just change the color. So pick whatever color you like. It does not have to be red. I'm picking red because red's a nice color. And let's just click and drag that onto our cube, and voila, we now have a red cube. Isn't that exciting? And you'll note nothing changed about the mesh, right? The mesh is exactly the same. But if you'll note, that parameter we were looking at a second ago that said default material now says cube material on it because we've replaced it. Does it make sense? So the structure of the 3D model is exactly the same. All we've changed is how is it rendering? How is it going to be visualized on screen? And how it's going to be visualized on screen is red. Cool? Okay. The last thing on here is the box collider. The box collider is used for physics. So I don't know if anybody noticed, but when I turned off the cube a second ago, there was still that like green box floating in space, right? That's the box collider. So it's a very common thing in AAA, Quad A, whatever you want to say, video games, to still use box colliders even if the object doesn't look like a box, because they're cheap. It's really cheap to take a look at a box and figure out if something's in the box or intersecting with the box. It's really expensive to take a look at something like, I don't know, a human being and figure out if something's inside of that sort of weird shaped thing, right? So it's a very common thing to do. So box colliders are perhaps the most common collider used in the games industry. Okay, I promised that I would talk about position, rotation, and scale. We have now reached the point where I'm going to talk about position, rotation, and scale. So position, unsurprisingly, is a position of an object. That's where it is in the scene, right? Now, this doesn't mean that it's where it's going to show up on the camera, right? Because it depends where the camera is relative to the object. So for example, if we take a look right now, we can see that this thing spawned in at 0, 0, 0. That's where our cube is. Our cube is at 0, 0, 0. Our main camera, on the other hand, is at 0, 1, minus 10. And that's why this looks like this, right? If our camera was in a different position, it wouldn't be able to see the cube. Does it make sense? It might be easier to imagine it in person, like if you imagine like my hand's the camera and my other hand is the cube, right? It depends where we're looking, whether or not we're going to be able to see the cube. Cool? So let's just do something really simple. Let's go back to our cube and let's like change the y here to 5. And it jumps up, right? It's higher now. Y is the up and down one. We also have x, so I can change that to 5. That's the left to right one. So 5 would be to the right, given our perspective. Minus 5 would be to the left, given our perspective again. And then finally, you have the z, and the z dimension, it looks like the coffee order was canceled because it could not be completed by the dasher. So it might be good to, yeah, talk about that later. Z is forward and back, right? So we have how close or how far away the thing would be, right? Make sense? So those give you the 3 dimensions. If you're moving a character in a video game, you are changing at least one of, if not multiple of these dimensions, right? So the very typical thing is to map these for like player characters to the inputs that we're getting. If this is a non-player character, you're usually using code to figure out what its position should be over time, right? Okay, I'm going to put this back to 0 just to even things out. The next one's rotation. Unsurprisingly, this is going to be how rotated things are. And it's exactly the same sort of thing. So x is going to be, if we imagine like a pole going along left to right, the x-axis, we're going to spin something on that pole, right? So if I do like this, it'll sort of like move as if it's moving along that x-axis, going back and forth. If we change the, oops, didn't mean to do that. If we change the y, again, that's as if, imagine a pole's going up and down. We're going to spin something on that pole. Change that by 30. You can see again, it's sort of moving like that as if it was spinning along that pole. And then finally, z's as if we were going a pole going forward and backward, and then we spin along that pole, and it goes like that. Cool? Really straightforward. Finally, scale. Scale is the size of the thing. Why is that on? That's weird. So for example, x would again be left to right, so I could make it wider. Oops. Oh, I see what happened there. It was going to keep it even. That's not what I wanted. Oh, come on. So this is the problem with using a different version of Unity than I wanted to use. Curses. Okay, well, this is because it's a cube. It's going to force it to be consistent in all the dimensions to keep it a cube. Let's see. I don't want that. I don't want that. Let's create a new 3D object. Let's get a let's get a cylinder on screen. Cylinders can be whatever they want to be, right? No, are you still going to be weird about this? Okay, we're going to move you a little bit so I can see you. Hello, there's my cylinder. No, there we go. We're good. Oh yeah, sorry. I should have said, Unity also gives you tools, so I can just directly click things in the scene view, and I can move them around. So for example, this tool right here, this sort of up, down, left, right one, move tool, if we grab one of these arrows, we can move it along that axis. So we don't have to change things by hand. We can move things around in this sort of view. Also, we have a rotation one. Unsurprisingly, that rotates. And we have a scale one. Unsurprisingly, that's going to scale. So I got a very, very tiny one, etc., etc., etc. Okay, does that help at all? Do people have a better understanding in terms of position, rotation, scale? I'm seeing nods from people who were looking confused before, so I'll take that as a yes. Fantastic. Okay, I'm gonna get rid of our cylinder because I really did just want to scrap with a cube for a second. I'm gonna reset everything. So let's go back to 0, 0, 0, 0, 0, 0, and 1. Oh, 1, please. Yeah, 1, 1, 1. Cool. So from here, this is, it's fine. We've got a thing on screen, but this is not a video game. I don't know if you knew this, but staring at a cube, probably not a video game. Some game scholars might disagree with me. Maybe there's a lot of playful experiences we could have in staring at a cube.
I have to go through like every single like big kind of movie.
Yeah.
Still require that. I mean, I'm just like, so you're staring at a blank screen.
Yeah. Watching paint dry, that can be a game. Just needs a magic circle. Anyway, I'm going to make a folder for the purposes of making things a little bit more organized in our project view, which again is sort of like the what's going to be saved on disk sort of thing. So I'm going to make a folder, and I'm going to, oops, didn't mean to click over there. You can, again, do that by getting to this plus and then going to folder. I'm going to call this scripts. So Unity is a scripting game engine. In fact, most game engines nowadays are scripting game engines. There didn't used to be back in my day. But basically what that means is that instead of writing just like a single big piece of code that will control everything, different components, different game objects in the world will have certain bits of code on them, okay? And they will sort of do things when they sort of process that bit of code that's sitting on them. And that's what's called a script, okay? So it's like a little bit of instructions that can be packaged and put on an object. So to be able to show that off, we're going to go ahead and create a script. So I'm going to go to create and then C# script. You can also do that by going to the plus and then going to C# script. We need to name this. So I'm going to name it something like cube script, just to be extremely consistent with my naming structure here. This is going to be a slight problem because some of you might click off this and then it will be having just like the default C# script name. If that happens, we can go through and we can edit things later. Don't worry, it's a fairly easy thing to fix. Some of you have already started opening up a scripting editor, which is good because that's the next step. So if we double click on your script, Unity will attempt to open whatever IDE you have installed on these computers. I don't know what that is. It might be Visual Studio, because that's what comes with Unity. It's probably going to be Visual Studio. I have Visual Studio, but I don't know what's on your computers. If you don't have an IDE installed, it'll probably just open whatever text editor you have, which is perfectly fine. You don't need a fancy IDE. Okay. Looks like some people are getting to this point. I want everybody to be able to open up the script. You've made a cool sort of arch. Okay, Visual Studio is opening on several of these. We got Visual Studio happening. You're dropping some things with the physics of Unity. Unity physics are bad. I don't recommend using them. Oh, they're horrible. Strongly do not recommend using Unity physics. All right, is anybody stuck on being able to open a script? Let me see. Yeah, no worries. Okay, so just go to the plus button and go to C# script and name it like cube script or something. Doesn't really matter what you name it. And then once you got that, just go ahead and double click it to open it. You don't even have anything open. Do you want some help? No? You're just going to watch? It's fine. All right, we've got scripts open over there. Okay, I think we're all right. It might make you sign in to an account, which is a very silly thing to require an IDE to log you in, but you know, this is the world we live in.
Physics bad.
Why is Unity physics bad? Great questions. They're extremely inconsistent. So if you wanted to have any sort of game that was reliant on physics, it would be a very bad choice to make use of Unity physics. They're also very expensive. So if you want your game to run on something that isn't like a high-end PC, it's a bad idea to use Unity physics. If you want to have some sort of physics in your game, it's certainly going to be cheaper to implement it yourself. And more consistent and better in every respect. It's non-deterministic, yes. All right, how are we doing over here? You managed to get to it? Hit the plus button for me. Top left by the project. Hit C# for me. Name yourself cube script or something equivalent. And then open that up. Okay, I think we're doing all right. Everybody else seems okay. Anybody else need a hand? No? Yes? We need a hand down here. As I was walking away. What's up? So go to window. No, window on the far right. Yep, go up. Go, look, move mouse up. Move mouse left. Yeah, go to layouts. Scroll down a little bit, it's about halfway. And hit 2 by 3. There you go. Yeah, no problem. That's what I'm here for. Okie dokie. Once everybody has gotten to this point, you should have your cube script or whatever you called it open up on your screen in your scripting editor. And this is the default. So if we just create a C# script in Unity, this is what it's going to look like. You'll note that we have 3 lines up at the top. We have using system collections, using system collections.generic, and using Unity engine. Using Unity engine is required because it's how we're actually going to interface with any of the components in the Unity engine, right? That sort of makes sense. Using systems.collections and using system_collections.generic are basically just so that you can have lists and arrays and dictionaries without having to add those lines yourself. Unity didn't used to have these as default when you created a new C# script, but enough people complained that they added them because it was just annoying. You ended up adding them yourself to basically every single script you used. From there, we have classes. So Unity is object-oriented. Do people know what object-oriented is? Anybody confused? Does anybody not know what object-oriented means? Does anybody not want to admit they don't know what object-oriented means? It's okay. Joseph's not even going to look. No, he's closing his eyes. No, everybody's good? Okay, phenomenal. Okay, don't worry, Joseph. They all know what object-oriented programming is. So we have a class. That class is whatever we called it, cube script in this case. And we're going to inherit, that's what the colon means there, we're inheriting from mono behavior. Mono behavior is necessary for us to inherit from if we want to be able to put this script on a game object. Does that make sense? So it just basically has all the basic stuff that Unity requires so that you can actually use it in a game. Does it make sense? Sometimes when you're doing like for real Unity C# stuff, you'll end up creating stuff that doesn't inherit from mono behavior because it's like an extra class or a helper function or things like that that you want to have, or like a singleton somewhere, these sorts of things. If you don't know what those words mean, don't worry about it. They're just sort of like, if you're going to do more advanced stuff with programming, they become relevant. They're not going to be super relevant today. From there, we have two functions that are by default in here. We've reached the interactive portion. Could anybody tell me what the start function does? So we have it runs when an object is made. That's the guess. Any other thoughts? Sorry, when it's first what? When it's first rendered. Okay, yeah. These are all good guesses. Okay, when the scene starts. So you're sort of all right. Start, unsurprisingly, is called the first frame update. So if we talk about frames in games, people know about like frames per seconds in games. People have heard this term before, right? So frames per seconds is just how many frames are going to occur in a second. So a frame update in Unity is one of those little microseconds updates in terms of what's going to be happening in the game, right? So if it's 60 frames per second, we have an update that occurs every 1/60th of a second. Does that make sense? So the way that, as I mentioned, we have these sort of Unity game objects, we have these scriptable things that go onto game objects, et cetera, et cetera. The way this actually works, and actually I'm going to use the whiteboard right now. I didn't think I was going to use the whiteboard until later this afternoon, but guess what? We're using it right now. Let's say that we had let's say we had three objects in my scene, O2, O1, and O3. These are my three objects in my Unity scene. If we're in that world where we had these three objects, and I had some scripts on this, so let's script S1, script S2, script S3, script S4, and script S5. These are all the scripts that are on these objects. I know I didn't name them particularly nicely. This could be called like cube script 1, cube script 2, but it would have taken me longer to write that, so I didn't. So what's the way this is going to work is that Unity is going to go through each of these objects in order. So O1, O2, O3, and it's going to call the update function on each of these scripts. So S1, S2 for O1, then S3, S4 for O2, then finally S5 for O3. Does that make sense? And what's going to happen is if update has not been called on this object yet, this is why I was saying you're all sort of right. If update has not been called on this object yet, it will instead call start the very first time it would call update. And otherwise, it will call update, which will be called once per frame going forward. Does that make sense? Cool. Okay, I'm now done being a whiteboard guy. I'm going to be back and being a writing on my computer guy like I promised I would be. Sorry that I'm so difficult to film. All right. Oh, sorry. Correct. Yeah, it's just start for the very first one. This doesn't super matter, right, in most cases, but there are edge cases where it definitely does matter, right? If you're trying to make sure that things occur in a particular order, right, it can become really troublesome. This can also become a really big problem if, like, you have starts on two different objects and one's dependent on the other, but the other one goes first, right? This is why these things are a problem. And
Call the update method however you start.
Sort of. Yes, sort of. Okay, so what we're going to do is we're going to write a little bit of code, okay? What I want us to do is we're going to just start very simply. We're just going to make this cube float up into the heavens. Sounds good? That's going to be how we're going to start. Any ideas? I know some of you already know Unity stuff. Any ideas on what we should be thinking about changing about the object, our cube, to be able to make it float upwards? People are saying y, people are saying position. Yes, this is it, right? We want to be changing the y value of the position. So if we go back into main Unity for a second, right, that's over here. If we're to click on our cube, I'll remind you that position, rotation, and scale all exist within the transform component. That means if we want to reference the position, we first have to reference the transform. Thankfully, this is really easy. How do we do it? We write transform, just like that. Lowercase transform will mean that we're going to talk about the transform component on the object that this script is on. So if we were wanting to talk about transform as a class, we would instead use the capital T transform. Does it make sense? The lowercase is like a particular object, a particular instantiation, a particular component. Cool? Cool. So once we have transform, guess what the next thing we want is? The position, right? Gives us transform.position. And from transform.position, this is if we, ooh, can I do this in this version of? Yes, I can. So if I hover over this, and at least this version of Visual Studio, you'll see that I can see the class. This is a vector3. This is a kind of object, right? If you think about like strings or floats or ints or things or so much and so forth like that, this is a very much a default Unity object type. It's not a primitive. There are still strings and floats and booleans, etc. in C#. They're still actually primitives, but this is a very common type of object, very common class that we're going to be using. And unsurprisingly, a vector3 is called a vector3 because it's a vector of 3 numbers. Whoa, blowing your minds, I'm sure, right now. And those 3 numbers are the x, y, z in this case that we were talking about earlier, right? So if we have the position, we can go ahead and grab the y value from that position. And then, let's just do something really simple. I'm going to be really flippant about this because this isn't going to work. Let's just do this plus equal 1. But it's not going to like that. It's going to be very against us, in fact. So Unity does have some sort of protections over data and where you can access things. If you're using Visual Studio, you'll get a nice little red bar here, and it'll actually give you prompt in terms of what the issue is. You can see here, cannot modify the return type of transform.position because it is not a variable. So the y of transform.position is read only. We can only grab its values. We cannot set its values directly. There's also a nice thing that I wanted to show you in here while we're here with Unity, which is if we go back into Unity, it's going to recompile the script. Come on, recompile a script. You might have got to make sure that you save. You can see in the bottom right there, there's a little wheel when it was recompiling. This is hard to see because I'm using the dark mode for Unity, as I'm sure several of you all are. You can see there's a little bit of a red script, red text down here on the bottom left. That means that our Unity project has an error in it. Unsurprisingly, it's the same error that we were looking at a second ago. But the nice thing in Unity is if we click that bottom left, we'll get up this little console window. If we click on the console window, this will break down, hey, what's the error? And the other super nice thing about Unity is it even points me to the script and the line of the script that's the problem. So this is hard to read, but it says cubescript.cs 16-9 or comma 9. So if we go into our cubescript.cs, our only script that exists, we can in fact see that the problem is at line 16, right? This is super handy. I find that this is the #1 thing that early users of Unity forget is available to them, and they'll go, I can't find out where the bug is. I can't find out where the error is. It literally tells you where the errors are in Unity. You just have to track it down. Cool? So this is very handy. So the way we're actually going to have to do this is we can't directly modify y. We can only modify position as a whole. So we can only change all 3 values of position at once. Now, this might make it sound like we can only ever change x, y, and z at the same time, but no. Because we can change them by a particular thing. We could, for example, change them by, in this case, plus equal to vector3 dot up. And vector3 dot up is just built into Unity. It is a vector3, unsurprisingly, that is 0, 1, 0, which is up. It's pointing up, right? And this will allow us to say, okay, I don't actually want to change the x and the y, or x and the z, apologies. I only want to change the y. Does that make sense? So if you were in a game where you wanted to have like motion controls where you move to the right when something happens. You could use vector3.right. If you want to move to the left, vector3.left, etc., etc., etc. Make sense? Pretty handy. Okay, so I'm going to go back to Unity, and we'll now get to some buttons we hadn't looked to in Unity before, which is that we have these nice play and pause buttons up at the top of the screen. So play is going to have us, which looks like a play. It's like the triangle on its side. For some reason, that has become the eternal play symbol, which is very funny. But anyway, that's going to actually play your game. So we're going to do a quick show of hands. Nobody hit this button yet. Don't hit this button yet. Don't hit the button yet. Don't hit the button yet. I want a quick show of hands. Who thinks if I hit play that the cube's going to go up? Show of hands if you think the cube's going to go up. Sorry? Sure. Yeah, you can take a look back at the code. Oh, that's PowerPoint. Who thinks the cube's going to go up? Show of hands. I'm going to hit play. Is the cube going to go up? We've got a couple takers, a few takers. Who thinks the cube isn't going to go up? Okay. Is anybody who thinks the cube isn't going to go up willing to guess why? Willing to put it into words? Yeah. Even though we called it cube script, that was just for us. We didn't actually tell the cube, hey, use this script. Does that make sense? So let's confirm, right? We're all scientists here. People forget that science is in computer science. So we have a hypothesis. It's not going to go up. Let's verify our hypothesis by hitting the play button. We're going to hit the play button, and voila, it's now playing the game. Can't you tell? Nothing is happening, right? So let's fix that. Let's make that better. So what we're going to do is just go ahead and grab our cube script over here, and just click and drag it over to cube. That's all. If you've done it successfully, once you've gone down and you've clicked on cube, over in your inspector view, you will now have cube script available to you. Okay? If that, for some reason, doesn't work for you, or you don't like the clicking and dragging, don't worry. If you go to the very bottom of the sort of inspector view on the cube of looking at all these components, you can see the Add Component button, and then you could find your cube script on here and add it that way. Don't add it twice. If you add it twice, it's going to run it twice. And because we're saying it to go up by 1 step every frame, it'll instead go up by 2 steps every frame, right? So don't do that. Don't do what I just did. If you find that you have done it, you can just remove the component by hitting this little dot, 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 and then hitting remove component. Easy peasy. You should only have 1 cube script on there or whatever you named it. Okay? Okay. So let's try it again. We have our hypothesis. Now that we've added the cube script onto here, we have told the cube, hey, every update, go up by 1 step. Let's take a look at what happens. I'm also going to make one other change here, which is I'm going to go to the dot, dot, dot thing on the game, and I'm going to hit maximize. Oops, I did not actually mean to hit maximize there. I meant to hit maximize on play. That's fine. We want to do play maximize. That's the one that I wanted. I do not want to individually maximize that one. So you should go down to this one and do play maximized, which will actually maximize the game view. So it'll be like your full Unity window when you actually hit play. And this will be a little bit more obvious when we're hitting play. So I'm going to hit play. And once it's reloaded, phew, that was very fast. We're going to do it again. This is my sound effect, obviously. You can see for just a moment as the cube whisks away into outer space, right? For just a second, we can see it, but it does, in fact, go up to heaven just like we wanted. Okay, if you do not have a cube that is flying up into the heavens, raise a hand, let me know if you're getting in trouble, and I'll walk around. You can also see if a neighbor can figure this out for you. Okay, so we want to not be maximized. Go to the dot, 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 and then hit maximize there. We just want to hit the play from play focused. We want to change that to, oh, that's not, oh, because you're currently playing the thing. Yeah, it won't let you make changes when you're playing the thing. Go to play maximized. Okay, so then I'll go to our cube. So we don't have cube script on it, right? So if you just click and drag cube script, put it on there. Now it's on it. And now if you hit play again, let's verify this works. It's going to reload, and it flies off. Cool. Okay, other hands, who's having trouble? Okay, walking over here now. Oh, you're also having trouble? What's up? Oh, you still have a compiler error. So double click on that and see it's the line earlier that we talked about. So go to your visual, yeah, you can double click on it there. That's fine. But it should already be open.
Sorry. What do you mean? What's the name?
The script. So go to your Visual Studio. Yeah. So you're still changing transform.position.y as opposed to transform.position. Oh, no worries.
I got it.
Transform.position plus equal to vector 3. That looks fine. Did you save? You did not save the script. So it didn't actually get your update because you didn't save. Now let's go back to Unity, and it should compile just fine. No, hold on. Type CubeScript already defined a member called update with the same parameter types. Double click on that or go to your Visual Studio because it's just going to open the script. What? You only have one version of update. That's weird. Go back to your Unity for a sec. Click on this bottom left. Just click on it once. Okay, let's see this. Click on the top one. You created two different CubeScript scripts. Do you see? We only want one of those. Delete the other one. Anybody else struggling? We okay? You good? Anybody else need help? Everybody else can have a cube going upwards. No? Okay. Also notably, if you end up creating a second version of your script that has the same name, Unity will not run. Every script name has to be unique, at least within the same namespace. Cool? Okay, nobody else is looking at me confused. Let's keep on going. So we have this problem right here, which is, if you might have noticed, your cubes will be going up very, very fast, right? This is a core problem in video games that I'm going to reveal to you right now if you are not already familiar with it. So there's this problem where right now, if we take a look at CubeScript, I'll bring it up just so that you can remember it in your minds. We take a look at CubeScript here, right? It's going one step up every single frame. So that means if your Unity versions locally are running at a very high frame rate, which they are, it's going to go up very, very quickly, right? Imagine if you were going 60 frames per second versus 15 frames per second, right? At 16 frames per 60 frames per second, you would have moved up by 60 units in 1 second. But if it's 15 frames per second, you're moving up by only 15 units in 1 second. Does this make sense? This is yeah, totally. And there's lots of old games that do not account for differences in frame rate, such that if you overclock the game and you run it too fast, all kinds of fun and wacky things become possible, right? So generally speaking, you do not want to tie movement to frame rate, which is what we are doing right now. We are moving each frame as opposed to moving according to like time, for example. So time would say, doesn't matter how long a second takes us, we're always going to move the same amount in that second, right? Doesn't matter how many frames we've got in that second. Does that make sense? Is anybody confused by my explanation just then in terms of what's going on? This is a very core problem in video games, so worth keeping in mind. Okay, so the way that we're going to fix this is by using something called time.delta-time. So what we're going to do is we're going to multiply this vector 3. People have done vector maths by now? I have no idea at what age people do what, or what grade people do things in. Okay, sure. So, yeah. So vector 3 right now is 0, 1, 0, right? That's what I told you vector 3 is. If we multiply any number times this vector, what we do is we multiply it by every position of the vector, every single one of these 3 dimensions, right? So if we were multiplying, I don't know, 5 times this vector, what we would get would be 0, because 0 times 5 is 0. Hopefully everybody knew that. 5 times 1 is 5, and 0 times 5 is 0. So we would get 0, 5, 0. Does that make sense? So it works pretty darn straightforwardly in terms of how multiplying vectors works. What we're going to multiply them by is by time.delta-time. Time.delta-time is your best friend when you are working with Unity and real-time movement. Delta time is the amount of time in between this frame and the last frame. So that means it doesn't matter at what frame rate you're moving at. If you were moving at, 10 frames per second, that would be a tenth of a second, right? If you're at 20 frames per second, it'd be a 20th of a second, so on and so on and so forth. But this means that in the same amount of time, regardless of machines, you will move the same distance. Make sense? So let's go double check what this ends up looking like. Go ahead and run this. And we can see it is now slowly, beautifully. You can almost imagine the angelic chorus that's going on with it, right, as it slowly ascends to heaven. Cool? Everybody's got that. They all have slow cubes rising, hopefully. It's a fairly straightforward thing. I'll jump back and I'll show you. Real quick, before I do that, though, I'm going to unmaximize this just so that we can watch in the scene view. If I go over to the scene view here and I hit F, I can focus in on my cube and we can watch as it slowly continues to ascend for all time because it will never stop because we have nothing telling it to stop ever, right? So while that slowly ascends, hopefully everybody can get to this point. All it takes is multiplying our vector 3 by time.delta time. Cool? Anybody confused? Anybody stuck? Show of hands. No, everybody's with me. Phenomenal. Thank you. Okay, so small problem. While this is beautiful and slow and majestic, it's not all that good. It's not a great sort of rate at which for this cube to run. If this was some sort of real-time control game, we would not want it to move at this pace, right? And generally speaking, we probably don't want things to always move at time.delta time pace, right? That would be really, really slow. It's a very small number. How can we fix that? How can we make it move faster? Multiply it by a scalar, yeah. Multiply it by just some other number, right? So let's see that if we just went through and multiplied it by, I don't know, 5. I'm going to pick 5. You can pick whatever you want. Let's go back and we run it again. Once it's recompiled, make sure you save or it won't recompile. And we hit it again. We're going to see a nice in-between, much more brisk cube rise. Cool? So you can pick whatever variable value you want for that. That's just some floating point value. Cool? Okay. But now we're going to get into another fun thing about Unity. So scripts, as I mentioned, in Unity are components, right? And if you'll take a look, if we look at any other component, right? We can look at our transform, our mesh render, etc. They have all of these like parameters, all these extra sort of like things you can control about them, right? I could directly go into the cube and I can change its position from the Unity editor, right? So we get this really fun thing in Unity because we can make those ourselves. We can give ourselves these extra sort of control points. So if we go into, once again, our cube script, we're going to define a class level variable. So to do that, we're going to use public, which is going to tell us that we can look at it, both within the Unity editor and in other scripts. I'm going to then name it, use a float as our variable type here. That's just saying that it's going to be a floating point number, right? So it's allowing us to have decimals and all kinds of other things. I could use an int instead, but floats are more generic. And I'm going to call it speed. And if I were to use this in this way, after it compiled and we went back over here, if we go back to our cube and we scroll down a little bit, you'll see we now have a speed variable, right? It's set to 0. 0 is the default instantiated value for floats. If you don't specify a value, it'll assume it should be 0. But that gives us this sort of number, right? And it's a number we can then play with and use however we want within our script. So, for example, if we go back over here and we replace whatever number you picked with speed, then we can have some fun. So if we do that, if you now have a line of code that looks like that in your code, then if we go back to Unity and we hit play, nothing is going to happen because our speed value is 0. And 0 times anything is 0. So it's not going to move at all. But this gets us to a very fun thing that we can do in Unity, which is if I go back over here and I turn this maximize back off, so I can see my game and my scene view at the same time. Take a look at my cube, and just do like that so I can see everything. I can scroll down to the bottom here with my cube, and I can change this value live as we're running. This is really helpful for prototyping, for figuring out like what should a value be, is like drastically making changes, right? So let's go ahead and I'm going to really quickly just change it to 1. Oops. Oh, the 2022 version locks you out. Oh, there it goes. Yeah, look at that. Look at that. Slowly rising because I've changed it to 1. But now what happens if I change it to -2? Watch as my cube slowly descends. Change it to 10. Oops, 10. It flies back up there. Change it to -40. plummets down below, etc., etc., etc. Change that back to 1 so that it will slowly rise as I'm speaking. Watch as it slowly comes back up. It got really far when I changed it to -40 for a little bit. So this is really nice, right? Because this is now giving us this sort of axis of control, this sort of lever on which we can now make changes to the game live as it's running. So this is a really handy tool. I don't think it's going to get back up there. It would need another 190 units before it gets back up. But the important thing is, if I hit the play button again, so I'm now going to stop it, it's going to reset to its initial value. Nothing will be saved in Unity while the game is running. I'm going to repeat it again. Nothing will be saved in Unity while the game is running. Why am I repeating this? Because so often people who are just starting Unity will hit the play button, they'll arrange everything just the way they wanted it, set up their level perfectly for what they wanted. Oh no, they hit the play button again and lost everything because they were playing the game and it wasn't saving any of their changes. So make sure anytime you're working with Unity that you do not make changes you want to stay while the play button is hit. This is also why I did the thing where I changed this so it was play maximize instead of play focused, because I wanted to make it really clear when the play button was going. Does it make sense? Okay, cool. Okay, that's getting us into basics of moving things around. I'm going to change the speed here to, I don't know, 5, put it to some default value just so it'll actually move when we hit it. And now let's get into input. So I want our cube to be our protagonist of this game. I don't know. We can change it out later. In fact, we will. Spoiler alert for where we're going. But what we want is to actually make changes to the cube based on buttons that we press. Okay? Does it make sense? People who've already worked with Unity might be familiar with this. But unsurprisingly, Unity gives you a wrapper to find where all of this sort of key press or other sorts of inputs you might have are. So I can go to if, oh, sorry, to make clear. I'm making an if statement here because we're going to need a conditional, right? We're going to need a conditional that says, if this happens, then do this, right? Hopefully everybody here knows if statements. But if you're not familiar with C#, you might say, I don't know what an if statement looks like in C#. It looks like this, right? You might be more familiar with Python or things like that. I don't actually know what you get taught here. So we're going to input, and then I'm going to go to get key. You'll note that if I start typing in get key, if you're using Visual Studio or something else, it'll prompt some options. We have 3 options here. We have get key. Get key will be true anytime that the key we specify is down. Get key down will be true only the very first frame that the key we want is down. And get key up will be true anytime that key is up. Does that make sense? And that gives you different things, right? So for like a jump, for example, you might want to use get key down because you only want the jump to happen the moment you hit the button, right? As opposed to like if it's continuous control, like a motion control, like moving back and forth, you probably want to use get key. Cool? Anyway, so let's go into this. We're going to do get key. And I'm going to use a key code, which is just saying that it's some of the existing keys that we're aware of, space. That gives us this sort of if statement. And then we need curly brackets to put behind it, to put around it. And then I'm going to move our line of code into there. So now our line of code looks like this. If you're used to Python instead, or similar things, I don't know what you get taught. Do you get taught Python? No Python? Sorry? Java. Okay. Well, in that case, this looks exactly like Java. Everybody knows how Java works. Everybody knows you need curly brackets, right? I don't need to explain anything. Phenomenal. Sometimes I'm places where they only know Python. They're like, why do I have a curly bracket? What is this strange world that I'm living in? Okay, so let's now go back into, oh, sorry, I used space. I meant to use up arrow. I'm going to swap that back out. Apologies. I got talking about space bar with jumps and I got confused. But you'll note that you can basically specify any common keyboard input. And in fact, Unity's input system is super robust. So if anybody has like a weird controller they like, it's actually really easy to hook up in Unity. But we're just going to be using the keyboard for today. Okay, so I do that. We go into Unity. We hit play. And then nothing's going to happen at first, right? Because I am not hitting the up arrow. And now my finger is moving down, and I'm going to hit the up arrow, and voila, it moves up. And I can now start and stop, and et cetera, et cetera, et cetera. Now, a single ability to just move up is not very exciting, right? So let's make some changes here. let's go ahead and in addition to our up arrow, I'm going to copy and paste a thing that you get told probably a lot you should never do when you are coding, but I'm not your boss. So we're going to do a lot of copy and pasting. I'm going to add one for the left arrow, for the right arrow, and for the down arrow. And similarly, I'm going to need to change inside of here so it's not just having us go up, but left, right, and down. Yep. Oh, it's just .w. It's just W. It should autocomplete for you. So yeah, if you, it's not autocompleting. It should be capital W. Did you use capital W?
There's no autocomplete.
Oh, well, your version is not hooked up to autocomplete. It's just capital W, and then it should work fine. Yes, if you'd like to use W, A, S, and D, you can use those instead. It doesn't matter. Cool? All right. Hopefully everybody got to this part. Hopefully everybody has 4 if statements hidden within their code. If we hit the play button, we now have full control. I can go up, I can go down, I can go left, I can go right. I'm so powerful. Watch as my cube dances around. If you do not have a dancing cube, let me know, raise a hand, and I can help you get to dancing cube step. Yeah, you need help? Okay, well, it's you gave it those controls in terms of the if statements, right? So let's take a look. Oh, well, you only added an if statement for going up. Well, your speed is negative. Go into the Unity mode, hit stop. If you could click on the cube, it's a negative speed. Just open it again.
Safe mode.
Sure, doesn't matter. Enter safe mode is just gonna like be some extra wrappers around it to try to make it stop. Everything cool?
Yep.
Okay. Anybody else stuck? Yeah, we got hands over here. Let me take a look at the hands over here. Oh. What's up? Not running. Well, you have an error, and you look in the bottom left. If you can click on that, let's take a look what your error is. So it says you're missing a curly bracket, the nightmare. So if we click, so all you're doing is you have 3 different input, 3 different transform calls all within the same if statement, right? So we need it to be in different if statements because it's different conditions that they should happen in. So open that back up. So what we need is we need an input line for, you'll also look that you're just writing input.getKey, which doesn't tell us what key to look for, right? So we need to look at that individually. Okay, what was your issue? So you see how all 4 of these say vector3.up? Yeah, so we have to tell it to go left or right or down when we hit left or right or down. It doesn't know, right? Anybody else stuck? Anybody else confused? Okay. Well, there's dot forward and dot backwards as well. But also, as I said, right, all this is 0, 1, 0. All this is left would be 1, 0, 0. All that, oh, sorry, left is minus 1, 0, 0. All that right is 1, 0, 0. All that down is minus, or 0, minus 1, 0, right? So we could set any vector we wanted. If I wanted, when I hit the left arrow, that I should go at a 45-degree angle to the left, I could do that, right? We specify what it is. Make sense? So it should just be whatever for the game calls on. This is just the most common stuff. Because it's the most common stuff, Unity has these default vector3 just already predefined for you. Cool? Okay, cool. So now we're going to take a small break from scripting for just a second, because the next thing that I want to do is I want to make this cube more interesting than just a cube. This is so boring. I hate that it's just a cube. Why did I just make it just a cube? What a terrible protagonist. What was I thinking? Let's get something more interesting in here, yeah? So next we're going to talk about importing stuff into Unity. So what I'm going to do is I'm going to go to a handy-dandy website called opengameart.org. Gavin was not aware of this, so I suspect most of you will not be. Opengameart.org is, unsurprisingly, a repository of open game art. It's accessible game art, whether that's music or sound effects or tile sheets or whatever. It's completely open, completely available. Some of them do require annotation or credit, so you have to say if you use their stuff in whatever, but it's free to use in any project, whether you have a school project, whether you have a personal project, whether you have a paid product, et cetera, et cetera, et cetera. So I want my cube to be more interesting. I don't want just a cube anymore. I want something that's fun. So let's see. I'm going to go with a low poly fox. Let's find out if that exists. And Jerome is slowly thinking about it. Ha ha! We actually have several. Oh my God, I have so many options. Oh, we have so many options that I can. I don't like that fox. That's a terrifying fox. We're not doing that one. Oh, that's taking too long to mode. I don't trust that this is actually low poly. I'm gonna grab this one. So once we have a 3D model that we're happy with, we can go ahead and download it. So I'm gonna download my animals.zip. And then let's go ahead and grab those out. Inside animals.zip, we have two things. We have a fox.dae and a Shiba Inu.dae. These are just 3D model files. We can see that they are in fact low poly. Look at that beautiful size, only 30-something kilobytes. Phenomenal. We love to see it. So it's really simple to import something into Unity. Most of the time, all you need to do is just click and drag. So I'm going to click and drag my fox.dae into assets. And upon doing that, we will see that I now have a fox in here, just like that. Opening up a 3D model in Unity can get a little bit, it can get more complicated. You'll note that there's like all sorts of extra import settings that had to be used. Different file types will have different things associated with them. I'm not going to get it in today, and there's really good scripting references for how each of those different components works. For our purposes, it doesn't really matter. What I'm going to do is I'm going to take my fox, now that it's in my project view, which as a reminder, the project view is like what would be saved on disk for this project. And I'm actually going to click and just drag it into my scene. And there we go. Now I have a fox in my scene. I'm going to set my position to, let's see, 0, 4, 0. It's going to, nope, I don't like that. I'm going to move it over here. Yeah, you go, no, I don't like that either. Yeah, that's slightly better. We can have you hang out over here, fox. That's acceptable to me. In terms of the position and the rotation, it's starting at -90. I want it to be, oh, that's not what I wanted. Let's actually keep you there, but let's move you this way. There we go. Now that's the kind of fox that I wanted to see. No, actually, that 5 was slightly better. Now let's keep that all the same. So now we have a fox. Just a nice generic fox. You didn't have to use the fox. You could have grabbed anything you wanted. I specifically grabbed a low poly thing because it was going to load faster, and I didn't want you to sit around while we slowly waited for every single time for the game to recompile because of our giant model in it. So this is just a nice thing to do. But you can grab whatever model you work. Anything will work. And right now, you'll note we have this cube script sitting on our cube. But just because we called it cube script doesn't mean it only can go on cubes. Our cube script is magnanimous. It can go on any game object we want. So I'm going to click and drag our cube script onto our fox. And if I do that, we can see we now have cube script hanging out on our fox. And if I hit play after it compiles, we'll now see, oh, hold on. It didn't actually like that for some reason. Why don't you? Oh, thank you. The default speed is still 0. But if we recompile that now, we can see we now have them moving together as one. What could be more beautiful than this? The reason why they're moving together as one is they both have cube script on it, and they're both set to a speed of 5. If I were to instead say, oh, actually, I think that's too fast for a fox. I think a fox should only move at 3. We can actually get this really interesting effect where our cube will move slightly faster than the fox in every dimension, right? So that's cool. But as I said, cubes are dumb. I hate cubes now, and so I'm just going to get rid of the cube. It's gone. I hate you. Goodbye. And all that's left is our fox, which I'm going to move to his proper place. Actually, don't know the gender of this fox. I can't recognize a fox's gender. Their proper place in the middle of the screen. And that's our new sort of setup for the game, which we can use going forward. Cool? All right. Everybody should ideally be able to hit this sort of step. If you cannot hit this sort of step, raise a hand. And I will begin to make my way around to ensure that everybody can join me in the land of dancing foxes. You probably did. Hit that play button. Look at him go. What's up? Sure. Okay. Can you click on it so I can read the whole thing? No. Just click once. Just click once. Unity engine input and Unis Windows.input. Ah, I see. You're using Unity.Windows as well. You can just delete the using Unity.Windows. If you go back to your script reference, look at the top of the screen, or scroll all the way up. You have an extra using Unity engine.windows. We don't need that. Just delete that. That would be if you wanted to publish the game to Windows. You might want to be using that. But just for this example, you don't need it. Cool. So try to go ahead and hit it now. Hit that play button now. Let's just double check that this is all working before I move on, and then just get called back if it's not. It does not look like it's on Fox. So click and hit. You're currently playing the game. Remember what I said. Yes. Don't make any changes while the game is being played. Well, we can click on our Fox. We can just add it directly. So go down the bottom. You see where it says Add Component, and search for cube. Like just start writing cube because that's what you named it. Or no, you named it sample scene. What? No, you named it new behavior. Okay. Okay. Sure. Yep. And now hit play. Oh, sorry. You need to change your speed to not 0. You see how it's on new behavior script? So change that to some other number. I'm using 5, but you can use whatever you want. Hit play. Now it will compile. And now hit those buttons. There you go. Anybody else having trouble with this? Okay. What's up? Did you download it? Okay. Can you find the folder? Okay. This is a compressed archive still. You need to unzip it. So hit the right click and then go to extract all in the middle there. Extract all. And then extract it to that location. Hit export. And now you see you have a bare Blender thing. Okay, so now gonna grow into Unity. Bring up Unity. So and then click and drag inside the folder, that bare, into your project view. And move it into the assets, move it up a little bit so it's in under assets. Yeah. Give it a second. This is a bigger file. You've chosen a bigger file, and so it will take longer, but it will eventually load. You can click on Unity now, and it will give you a little like, oh, yep, there it is. So now click and drag your bear into the scene. There you go. You probably want to remove the cube and add your cube script to the bear. Cool? Yeah, no worries. Anybody else stuck? Everybody's been able to import a 3D model? Okay. I would assume that you can. Okay. Now we have a 3D model from our whatever 3D model you end up using. But you'll note right now, if I can get everybody's attention once again, right now there's no collider on this. So remember what I said earlier about how the collider was how we actually figure out sort of if the physics are going to like hit something like that. We figure out if something's being detected. So if we want this fox to have some sort of interaction with any other objects, we probably want to give it a collider. Easiest way to do that is to go to Add Component. And then I'm just going to add a box collider because, again, even if it's not shaped like a box, it's still the easiest, cheapest collider we can possibly be using. I do that. If you look in the scene view, so I'm going to select Fox in the hierarchy and hit F when I'm looking at scene, we can see we have a beautiful little prism surrounding our fox now. Or your bear or your Shiba Inu. I don't know what you ended up using. You can use whatever you want. I'm not your boss. This is really nice. This is actually one of the nice things about Unity is that it's going to set the box collider automatically, or attempt to, so that it matches the size of whatever model that you've given it, which is really handy. Not all game engines do that. Sometimes you have to set it by hand. But now we have this nice little box collider surrounding our fox. So let's give our fox something to grab. So what I'm going to do is I am going to make a new component or a new game object. So I'm going to go into game object. I want to go to 3D object, I'm going to go to sphere, and then I am going to rename this sphere apple, and you'll never guess what I'm going to do next. Remember that cube material from earlier? We didn't just make it for no reason. It wasn't just to make the cube red or whatever color you ended up picking. Because guess what? We can use a material on any object. Come on. There you go. So if you used a purple one, maybe it's a grape. If you used a blue one, maybe it's a blueberry. If it's yellow, maybe it's a lemon. I don't care. It's entirely up to you. You could even input a separate model here. But what I'm looking for is just something for this fox to get, right? Something for this fox to grab in the game. Cool? Okay. So let's make this really simple to start with. I'm going to put this apple, in my case, just a little bit further away, so it's a little bit further to get. Put it to like, I don't know, 10. So it's right there on the edge of the screen. And you'll note that if I just hit the play button, we can move our fox directly into our apple, and nothing will happen. Embed that circle into our back. Have a giant lump on the back of this fox. So, once again, unless we tell Unity what to do, it won't do it. It doesn't know, just because I said aloud that I want this to be a collectible, that it should be a collectible, right? We have to write code for that to happen. Make sense? Cool. So that's going to be the next thing we want to do. Let's figure this out. Back over here. So what we probably want is some way of checking to see if the fox is touching the apple, right? But at this point, we need to make a decision. And this is an important decision. This is a decision that comes up a lot in terms of game development, which is where do we want that logic to be? Do we want that logic to be on the apple? And for the apple to check, hey, is the fox ever touching me? Do we want that check to be on the fox to say, hey, am I ever touching an apple? If we want it to be on the fox, should it be within the same script we were using earlier or a new script? These are all sort of important decisions to be making when it comes to game development. In general, if you want these sort of repeated behaviors, something where this is a script where the code on it is going to occur across several different objects, we would make it a separate script. But if this is only the fox that's ever collecting these apples, we can just put it all within the same script because it'll just be a bit more consistent. So what we're going to do is we're going to go back to our cube script, which is increasingly not about cubes. Maybe we should have named it player script or something like that, and that would have been a little bit more consistent, but oh well. And we're going to add a new function in here. So there's a whole bunch of other mono behavior functions. I'm actually just going to bring up the mono behavior scripting reference just to show you all, because I think this will be a good thing to look at. So if you just Google mono behavior and Unity, that will bring up the mono behavior component here in the Unity sort of discussion or the Unity scripting reference setups here. It says a lot of information here. It has the mono behavior sort of breakdown of what all it works, et cetera, et cetera. Generally, you're not going to need to read this unless you're like, oh no, I have some sort of weird bug, and now I need to understand something in more detail, and then you might need to read it. But otherwise, you don't need to. And we can see that we have a whole bunch of functions that are sort of built in here, right? And you'll note that I scrolled down a particular amount so that on screen we would see on collision enter. Unsurprisingly, that's going to tell us something about when something else has entered our collider. If you don't believe me, Unity says right next to it, on collision enter is called when this collider slash rigid body has begun touching another rigid body slash collider. Isn't that convenient? It tells us exactly what we want. And in fact, this is the way that we can check and see, hey, is this touching an apple? Make sense? But if I wanted to do something else, like, I don't know, I wanted to draw gizmos or connect to server or become invisible or check and see if the application's quit, etc., right? These are all functions that are just built in to anything that's inheriting from mono behavior. Make sense? Okay, so let's go ahead and use on collision enter. I'm going to click on it so we can see here an example. If you click on collision behavior enter, it will give you an example of how it gets used. You can see that on collision enter takes an argument, which is collision. This is a type of object, right? It's you can see here, it's a collision is the class, and collision is also the object name. Again, capital means it's a class, lowercase means it's a particular instantiation. And this is an object that's not like a game object. This is an object in the typical programming sense. This is just some information, something holding some information about what kind of collision just happened. Okay? So let's start really simple. Again, I'm going to copy and paste. Don't listen to anybody who tells you not to copy and paste code unless they're Joseph. In that case, listen to him very intently and never copy and paste any code. And all we want to do in here to begin with is I'm going to add a debug statement. This is also referred to as a print line. Printing, if you're not familiar enough already, in CS is the most common way that you do debugging in CS, right? The first thing you should try to figure out when you've got a new programming language or a new piece of software or whatever is how do you print something in it? In Unity, there's actually several different ways to do it, but we're going to be doing debug.log. And I'm just going to write, I hit something, exclamation mark. And let's add a semicolon there at the end to end out our line. It's just like Java. It's actually really convenient that you all know Java already, because I don't have to explain some things that I would otherwise have to explain. So this, now, we can see here is on our cube script, which means that any time that something enters this collider, it should then go ahead and have a little debug.log that says, I hit something. Okay? Okay. So another of my dreaded questions that I'm going to ask for everybody to vote one way or another on. If I'm going to hit play right now, and I go ahead and move my Fox into my Apple, do we think that on the I hit something debug statement's going to pop up? Who thinks it will pop up? Okay, we got 4 hands. Okay. Who thinks it won't pop up? Okay, we have 3 hands. Anybody who thinks it won't pop up, can you say why you think it won't pop up? Does an apple hit the collider? Does it have a collider? Well, good news, we can double check that. The apple does in fact have a sphere collider on it. So that's good. Any other thoughts? Okay. All right. It's good that you're getting wise to my games and you're being critical. Let's test. There's a whole bunch of abstaining, by the way. It's a democracy. It's so important that everybody votes. Okay, so I'm going to move my Fox into my Apple and see what happens. Nothing. This is a trick question. It was a trick question because, as I mentioned before, Unity physics are really bad. Unity physics have all kinds of weird rules on when colliders are going to be detected or not. It's arcane. It makes no sense. There's no reason anybody who predicted yes would have thought that they would have been wrong, because you would expect by any logic, which is what programming is based on, that that should have worked, but it didn't. So there's a pretty simple solution here, which is we have to use a rigid body. So we're going to go on our Fox. We're going to scroll down a little bit. We're going to see where it says add component, and we're going to add a rigid body. Don't do a rigid body 2D, do a regular old rigid body. Rigid body is the sort of crux of the Unity physics system, right? You'll note that we have a whole bunch of things that are associated here. Initially, we have a mass, we have a drag, we have an angular drag, we have is kinematic, we have use gravity, we have interpolate, we have collision detection, et cetera, et cetera, et cetera. We have a ton of stuff that's on there. If I just hit play, something kind of wacky is going to happen. I'm hitting play. Let's take a look. And my Fox slowly drops off the edge of the Earth because now we're using Unity physics. Oh, joy. We have Unity physics in here, and that means that it's going to, by default, act like it's a 3D object in a sort of simulated fashion, including having gravity. We're not going to do that, though. If you go over here, you can see where it says use gravity. We're going to turn that off. Now let's hit play again. Now it says it's not using gravity. Everything should be normal, right? Let's take a look. I'm going to slowly move my Fox into my Apple. Let's see what happens. You'll note my Fox is sort of like, oh, yeah, everybody notice what was happening there? I'm going to do it again. I'm going to slowly move my Fox and my Apple, and I'm still hitting the right arrow. 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 And it slowly moves off to the side, right? Again, unity physics are awful. Never use them. So unfortunately, we have to use a rigid body, but thank goodness we can completely turn off unity physics. The way we do that is we scroll on down to is kinematic down here. If you do that, is kinematic, for whatever reason in Unity, I don't understand why they named it this, but they did. This means I should only be controlled by code. Whatever game object this component is on should only be moved by code, not by the default Unity physics. To be clear, the reason why it was kind of like bouncing off and slowly moving to the side was because it kept on hitting the sphere, right? And then it was like bouncing back and slowly rounding around. Exactly. Slightly moving. Exactly. It's a nightmare. And the worst thing is, you noted that like several times where I hit it, it was like moving to the left of the sphere, right? So it was going backwards behind the sphere. If I'd done that enough times, sometimes it would have gone to the right of the sphere for no reason. Unity physics. Anyway, now we've hit is kinematic, so we've solved all our problems, right? Let's double check. Go ahead and hit the play button. Go ahead and go over here. We can now go fully into our little sphere, but there's a small problem. I don't know if you noticed it. Well, it's not colliding. That's one thing, but we're not even getting my update from earlier. Yeah, it's not even triggering anymore. I'm going to turn off is kinematic, and you can actually see the trigger. Earlier, you were probably distracted by the bouncing fox, but I want you to take a look at the bottom left side of the screen. This is now with is kinematic off. I'm going to slowly bounce into this sphere, and look, you see the hit something? I hit something, right? So that's happening. It's working. We're in fact getting that, right? So this is where the other fun thing about Unity physics comes in, which is if you are using a rigid body kinematic object, it will only interact with certain other rigid body kinematic objects. So one more step to get through here. We're going to go back to our apple. We can see it's using a sphere collider right now. We're going to add a rigid body to this one. We're going to turn off gravity. We're going to turn on is kinematic. And if we do all of those things, we go back over here. And even as I'm able to, oh, I forgot to turn off is kinematic on the other one. My bad. Go back over here. Slowly get over this way. Oh no, it's still not working. I think this is a Unity 2022 version. This is why I don't use this version. All right, we're going to do a fun thing, which is called Googling. Enter, there's usually just like a table for these things. What's the most recent updated one? Does it not have the setup? Special the collision, glass. No. So when the collider rigid body has begun touching another rigid body collider. No, that's not what I want. Yeah, there's supposed to be there was a table of interactions. This no longer exists. This is a problem with Unity. Oh my goodness, they just deleted the forum. I forgot. It might be inside here. Let's find out. Dynamic node order is also trigger type is trigger on collider shapes. Collider surfaces, collider types. They should be. I'll complain about them as many times as I need to. One of the bridges has to be non-kinematic and both need to be attached. I see. One of them needs to be non-kinematic. Ugh. All right, we're going to make this apple non-kinematic. If we do that with the apple, will you calm down, Unity, please? This is the most recent version. There we go. Yay! Okay, we managed to get there. So technically we need to have in this version of Unity, we need to have at least one of our objects be non-kinematic, which means that Unity physics is allowed to run on it, and then it's allowed to do this. There's actually one other kind of Unity collision setup. It's called on trigger enter. It's a little bit less finicky, but we're just going to use this one for today because we've already spent enough time on this. We're still going to eat the apple, don't worry. I promise you, we're going to destroy this apple. Okay. So right now, all we're doing when we hit the apple is we say, I hit something. We want to do something that's a little bit more interesting than just saying, I hit something. So we're going to actually try to destroy the apple here. But how on earth are we going to do that? The only information that we have about what we just entered is this collision. So collision is telling us the information about what we just hit, right? So from there, we can figure out some stuff. So for example, we could do something like if collision dot, and we can see here the things that it has, dot collider, for example, dot name equals apple. So this would let us like check to see if it's an apple, for example. And then if we were to like run this, we could only hit apples and do something like that. That would be a beautiful and sort of nice way of just double checking that we had an apple before we destroyed it. We're not going to do that though. I'm instead going to destroy, which is the word that you use for, unsurprisingly, destroying things, whatever game object I just touched. So in this sense, this game would not work if I were to add some like other thing in here that's like, I don't know, an enemy or something like that, something I would want to avoid. But I just showed you if we have enough if statements, we could like add extra if statements there to like split out what the behavior should be. But anyway, let's just do this. On collision, enter, destroy the game object. We're still doing okay on time. There's 2 more steps I want to get to today. So let's double check what happens. We go over there, we slowly go over here, and pop, our apple disappears. Once more, in case you were not paying attention, I go over, we get over to this apple, line it up nicely, and ta-da, it disappears upon enter. That's literally all you need. It will destroy anything it touches with this. Cool? Okay. With this, we're going to get to one more very important aspect of games, which is sound. We haven't had any sound yet. I've given you visuals, I've given you mechanics, right? We have no sound. So sound in Unity is similarly easy in terms of importing as with like these 3D models. So I want to grab some sound effect for when I hit an apple. That sounds reasonable, right? So I'm going to, once again, go on back to opengameart.org. If it loads. There we go. And I'm going to look for some kind of like crunch sound effect. Let's see. Crunch. Yeah, I want like a crunch. Paper crumple? No. Crunching bones? Eating crunch. Do I have no sound? Let's find out. Oh, that's way too long. Where's apple bite? Oh, okay. Seems reasonable. Now, for whatever reason, if you prefer to like go a bit retro with this, there's a ton of 8-bit sound generators out there. So for example, if I just Googled, but JSFXR is a common one that I've used, we could instead grab like a power-up sound. Oh my God. Ugh. Why are all these awful? Let's maybe go with a, do you have a coin or something? Pick up. Okay. Hey, that's perfectly reasonable. You'll also note here, this is like a sound generator here. This is basically like a tiny little like synthesizer. And this is going to allow us to like change out the sound qualities as needed. I'm going to download this one because I think it's a little bit nicer and shorter than the extremely long apple bite that we found on opengameart.org. But for different things, you might want different things, right? All you need for the purposes of following along with me is some sound effect. Just download some sound effect. I've done this before, and a student like grabbed the entirety of some meme song and like had that play every single time something happened. So, you know, go with your heart. Anyway, so we'll go back into Unity for a second, and then we're going to want to grab this sound that I've just downloaded. I grabbed pickupcoin.wave. We're again just going to click and drag it over into my assets. So we should have pickup coin over here. You can see over here. As with the model, we have a whole bunch of import settings that are telling us how we should go about importing this thing, right? I'm just going to go with this sort of default here. You can, again, change that out if you find that you need to for your particular game. Then we need some way to tell the Fox to play this sound anytime that it does this collision thing, right? So to be able to do that, what we need is a reference, a way of sort of pointing a reference to the sound effect. Does that make sense? The way that we're going to do that is we're going to go up to the top of our code, and just as we did before with creating a public variable, we're going to create a new public variable. Audio clips in Unity are called audio clips. Isn't that convenient? So we have a public audio clip. You could also call it public audio clip byte. It doesn't matter what you call it, but that's what we're going to, you just need some reference to it, okay? Once we have that, so you should have that line there or something like it, Gesundheit. If we go back to our Fox and we take a look at our cube script, which is increasingly not what this script is, we can see that we have this sort of none audio clip. So it's unsurprisingly, when it's instantiated, there's nothing in it. I can hook it up with the right thing in two different ways. If you click this little like target or bullseye sort of sign down here at the bottom right, if you click on that, you'll note we only have a single sound effect in this whole project. Isn't that convenient? So we can just grab it like that. But you could also just click and drag it into that slot, just like that. Okay? Once we have a reference to it, well, you'd think that we could just go ahead and play it. But there's actually one more important thing that we need in Unity to be able to play sounds. So audio clips tell us what the sound effect is. Audio sources allow us to play sound effects on them. So we're going to add one more component into our Fox. That's going to be an audio source. Well, just like that. And all this is it's going to be something that's going to let us play sound effects on this object. Whether a sound effect is on an object, is playing on an object, matters if you're in a 3D Unity setup, because the distance to the camera will tell us how loud that sound effect is. Does that make sense? It's just like sort of approximating real world, you know, how sound decays. So now that we have all of that, we're going to need to grab our audio source. Oh, will Unity, this version of Unity let me do this? Oh, it sure won't. Okay, that's fine. I lied. Sorry. We need one more step in here, which is that we need a reference to that audio source in order to tell it to do things. Okay? So I'm just going to call this audio source with like a lowercase, just like that. Oh, that auto-completed in a way that is worrying to me. It makes me think that actually there is a second thing, but it seems like it's okay right now. So we can go ahead and grab an audio source. Once again, we can do that by either clicking and dragging our audio source thing that we just added into this slot that we just created, or we can hit this little target. You'll see that we have a single audio source in the scene. Isn't that convenient? That's our Fox. So now we have a reference to it. And now that we have all of that, I can say audio source dot play one shot. This is going to be play one shot as in just play it a single time, right? And don't worry if you get interrupted by another instance of it. Play one shot, and then the clip is, I just called it clip. We do all of that. We let it compile. We go to the play. We let it compile a second time. I slowly move my Fox over to the apple, and beautiful. Now, there's one more cool thing about this, which is our apple is like beautifully set up as this apple now, right? So if I were to do something like, oh, I don't know, right click and duplicate this. So now I had two apples. I'm going to call this Apple 2, just like a famous computer. And if I move this apple over, I don't know, over here, it's going to have exactly the same stuff on it, right? So we can go over here. Ta-da! We can have as many of those as we want now that we've set it up that way. Okay, let's make sure that everybody can get to this part, that you can have apples showing up or whatever other kinds of collectibles you want showing up. If anybody got stuck on something, raise a hand so I can see, and then we'll go through one more thing. Okay, I'm going to go left to right this time. But yeah, of course I can show the code again. But isn't it important to make sure that you're not just copying and pasting this code from me? I'm allowed to copy and paste myself, but you're not allowed to copy and paste me. You gotta actually think critically about what the code's doing. But yes, of course I can load that up. Sure, here's what I'm going to do. Just so that you can see everything that we just added at once, I am going to copy and paste because the position of this function doesn't matter at all. I'm just going to move it up to the top here, and now you can see everything. Anybody else stuck on anything else here? What's up? Okay, so So if you go ahead and stop playing, and you click on your lemon or whatever it is, you see how this one is also is kinematic. So as I mentioned, both of them, one of them has to not be is kinematic for the collision to happen. So click that one off. Now hit play, do it again. This is the annoying thing about this version of Unity. There you go. Now you just need your sound effect stuff. Anybody else stuck on anything? Of course. I'll give you a second. Ideally, I should be hearing little pinging or other sorts of noises happening around as people get things to work. To get to the point where you can move your thing around and get some stuff out of it. Dark pigments. That's what we will need Matt back next year to show us how to make our own Unity 6. Paint dry simulator. Haha. I'll redo it. Hey, I heard a sound effect. That's good. I want more. I need to hear more sound effects. If you, my goodness, some of you are going a little overboard with your number of things. That's fine. Need to get to the point where everybody can collect the objects and make a noise. Yeah, what's up? It won't destroy. Wait, what is it not doing? Show me.
He's already colliding, so I don't expect the sound right away.
Well, you should probably move it so it's further away. So you actually have to. So again, don't make changes when the play button's on. No worries. Yeah, move him back over there. Hit the play button. I don't think that's your problem. Why don't you show me your cube script? Okay, so you have on collision enter, you have audio source dot play one shot clip, you have destroy clip collision dot object. Okay, that seems reasonable. Okay, hit the play button for me. Let me see what's happening here. Okay, so it's not destroyed. It's just off screen, right? We can see it right there. So now move your Fox into it. Move it down a little bit. Okay, so you have the same thing that those two had. You need to change your sphere to not be is kinematic. So hit play. Go to sphere. Turn off is kinematic. Go back to play. Move your Fox into your sphere. Also, you'll note your sphere is off your screen. This game mode is what a player would actually see. So you might want to consider moving that to a location where you can actually see it on screen. So if you grab the up, down, left, right sort of arrows thing, you can whoop, and then select it. Yeah, yeah. And now you can move it around. So you need to be able to see it on the screen view, right? So I don't think you're gonna get it like that. Click on your main camera real quick. So you see here's the view, right? So your sphere is actually below things. Let's make this simpler. Click on your sphere, hit the play button real quick, because you're again making changes while the play button is running. And let's just move your sphere to the same starting point as your Fox, right? So your Fox is, if we just click, is starting at 0, 0, 0. Let's start the sphere at 0, 0, 0. Just move it to there. So just change those values to 0 and 0. There you go. Now from there, we just move it over to like the right, which would be changing like the X value or the Y value. There you go. Perfect. That's fine. Okay, if you don't like that, that's also fine. Good. Hit the play button. Okay, now let's move your Fox. Yep, move your Fox into it. Okay, so that's not working. Let's go ahead and see why that would be. Hit the play button for me again. Click in your Fox real quick. Scroll down a little bit.
It says he needs me kinematic already.
Yeah, he should be kinematic. Weird. Let's go back into your cubes, your new behavior script. Okay, on collision enter. You have a green line under uncollision enter. Can you go over that? Variables captured this. On collision enter is called when this collision has begun touching the local function collision enter is declared but never used. Interesting. Why is that? Can you scroll up a little bit? Okay, so that all seems fine. Scroll down a little bit. Let's do this. Let's just go to, let's just add a debug statement inside on collision enter. So add a new line here, write debug.log, capital D, but that's fine, it autocorrected, capital L for log. And then make a string so yeah, pass it a string that just says like hi or hello or something. So we know that it gets there, and then add a semicolon at the end, and then save that. That may have been the problem if you hadn't been saving it this whole time, now that I think about it. Oh yeah, I wonder if that was the problem. Hit the play button.
It's still playing. Rose on the
Oh, it definitely is colliding with things. I see a second collider in there. Oh, you don't have a collision. You don't have a collider on your Fox. Hit play. Yeah, there's no collider on this Fox. I think you missed the thing about adding the box collider to the Fox. It has a rigid body, but not a box collider. So scroll down to the bottom, hit the add component, hit box collider, and now hit play. Okay, so we're definitely getting collisions happening there. What on earth is happening? Hit the play button for me again. Let's click on the sphere real quick. I want to just look at the sphere just to make sure I didn't lose anything there. Yeah, well, it has that, but that's fine. That's all fine. Go back to your Fox. Scroll down.
Sorry, I broke it. So
It's fine. That all seems fine. You're saying that it's playing it from start?
yeah, so if I hit, you can listen. Yeah, exists.
I can't hear anything.
Okay, so you don't want this.
Oh, I see. Oh, that's because if you go to your Fox real quick, hit the play button, go to your Fox real quick, scroll down a little bit, see where it says audio source. You've added the crunch to here, and you have this thing that says play on awake. So you want to turn that off. So now it won't start on awake. That's the reason why that was happening. So your on collision enter just for some reason is not working. So let's go back to your script real quick. I want to take a look at your script. I wonder if you misspelled it. On collision, do we have two L's? We have an ISION, that's all fine. Enter, yes. Collision, that's a capital, that's fine. I think there's got to be some problem there. I suspect that it has to be that there's some like misspelling or something on this that I'm not seeing. No, it's recognized it as on collision enter, but it's recognizing that it's never being used. I have no idea. Okay, just delete on collision enter. Just completely delete it. Just, yeah. Delete the whole thing. Okay, save this. Okay, now let's make a new, do you go to, oh, wait, hold on. Oh, go back, go back, go back, go back. You created on collision enter inside update. You put a function inside a function. That's what happened. Hit undo a couple times so we can get that back. Now copy that. Okay, now delete it. Now move it outside of this, no, lower than that. Yeah. There, put that there. That's what happened. Now save. Let's go back. Let's double check this is all working. Come on back. Hit that play button. Let's see what happens. Move that into there, and ta-da! Now the problem is that it's not playing anything because you don't have the audio clip hooked up or the audio source hooked up. So that's the next thing you're going to need. Again, don't make changes while the plays button is running. So if you hit the little target, little like bullseye next to it, click on that, and now you can click on that sound, yeah, and close that out. And then you click on below where the audio source is, click on that, and click on your Fox, close that out, hit play again. I'll do it one more again. We'll get no warnings, no errors, and we're okay. Cool? Anybody else stuck? Anybody else having problems? Somebody has made way too many apples. What's up?
So, all right. So, when I have audience before the destroy,
Yep.
you know, it actually is not playing the sound or destroying game objects.
Okay.
Yeah.
So you have errors. So click on that. Yeah, because you didn't reference the audio source. You didn't set up the audio source reference. So go back to Unity, hit play. So there's a null object. You're basically calling something on a null object. So no. Just hit play the one time to stop it. Let's go back to your Fox. Scroll down to where it says cube script in the inspector view on the far right. Scroll down a little bit. You see, oh, no, too far. Just a cube script. Oh, you didn't add the public variables. So go back to cube script. So you're referencing, you're saying audio source, but there's no variable called audio source. Oh, you didn't make them public. So you can't reference them if they're not public. I mean, you could reference them inside the script, but there'd be no way to set their values outside of it, inside Unity. So let's go back to Unity. And then we take a look over on the right by the cube script, and you see that we now have two nones. Click on that. Yep. Yep. And then one more. Yep. And then hit the play. And scroll to the right. Beautiful. Okay. Anybody else stuck? Yep. Let me see. There's one more thing I want to do after this. Yep.
So like added the script to make my profile.
Okay. Okay.
And then it was when I oh, I don't
Sure, because you're there, it's off camera. So your bear is so massive, taking up the entirety of the camera, right? So okay, let's take this step by step. So let's first of all deal with the fact that, can I touch the mouse? Is that cool?
Right.
Okay. So are you using the arrow keys or what are you using?
Arrow keys.
Okay. So you're completely right. I'm not seeing that move. Let's go ahead and turn off the maximize for just a second. Let's take a look at this bear. We see it's there. And ooh, hello. That's not what I wanted. Bear. Go over here. Nope. So it is moving.
Okay.
Oh, I see what you did. You put the cube script also on your camera.
Oh, okay.
So your camera is moving at the same rate as your bear, and so you can't tell that it's moving. So if we take a look over here, no, it's not. Oh, what happened? Hold on, we can fix this. So if you go to the search bar up here, you can actually search and see what all has cube script on it. So we have just bear, so that's fine. And that's fine. So it was moving, but why couldn't I see that it was moving? That's weird. Huh, how bizarre. We're just gonna stop maximizing on play for just a second until I can figure out what's the heck is happening here. So you see, that's definitely moving.
Oh,
That looks fine. I can definitely see that it's supposed to be moving on the main camera. Is there an extra camera in the scene? Did you somehow add another camera?
so this one here because it was pointing towards the bear.
Yeah. That's the right one.
Okay.
Oh, you added a second camera. Oh, your model came with a second camera.
Oh, okay.
Whoever made your model added a camera to it.
Okay.
So we're gonna kill that camera.
Then it has the main.
And now we have this one. So the camera that was on the bear was unsurprisingly moving with the bear. What a surprise, right? And so because of that, we had this problem. Okay, so now let's deal with your sphere problem. So here's your sphere. Let's actually move to the same location as the bear to start with. I'm actually going to collapse that down. So it's at 0, 0, 5. 0, 0. Ooh, hello. 5. So that starts you there. And let's just move it a little bit more like to the right so we have some distance from it. And then let's go over this way a little bit slowly, but that's chill. Okay, so we're currently having no collision. Also, you'll note, you can see it on this view. You see the little suns on here?
Yes.
That means that the bear has its own light sources on it.
So
We probably don't need that. So we're going to get rid of these 3 light sources that just come with this bear. This was assuming, the model you download was assuming that this was going to be used as like, I don't know, for like some sort of like set piece or something. It was not expecting to be used as like a character in a game.
okay.
Does that make sense?
Right.
So it was like coming with its own ways to look at it and light it.
And if we had the empty basically scene now to download the camera and the lights would be
Correct. It would already be in there. Okay, so let's see. That looks fine. You have a box collider on it. What does your box collider look like, by the way? Ooh, I do not see a box collider. Oh no. What? Where's your box collider? Your size of the box collider is 0.
not really there. Okay.
It's not really there. So now we have now we have a so unfortunately for you, unlike for my fox, because I only had 1 object,
Right.
you had like 4 objects in here.
Custom.
Yeah, we're gonna have to set this ourselves. I think that's reasonable. Let's just go with that. Okay, so now we have a collider on that. We have a sphere collider on that. We have a rigid body on that. We have a rigid body on that. Let's see if this will work for you. Go over there and Okay, so it's now colliding, so that's good. It means that we're actually getting something here. But I think your cube script is not set up. Oh no, so it is on collision enter, audio, play one shot, audio clip, destroy collision game object. That all looks okay. Why aren't we getting that? Sphere collider, that's all fine. That's all fine. Cube script is on there. On collision enter, that's working. Let's just add a debug statement. Let's see if we're getting anything in here or if there's like some other problem in here. I'm just gonna write hello. So we see if we get anything on there. Let's go back to Unity. Oh, I think you have the same problem that, aha, it just never saved. Okay, so now we've saved it. Now we can set this. Oh, hold on. You put the audio source on the sphere. We don't want the audio source on the sphere. We want the audio source to be on our bear.
Okay.
Because we want the bear to be making the noise. We don't want the destroyed thing to be making the noise. Okay, one more check. Get over there, and there we go. Cool. Yeah, no worries. Anybody else stuck on anything? Yep. There's one more thing I want to try to do today before we take the break. We'll be a little on time. We'll figure it out. We're gonna get there. What's up?
Destroying the block.
Okay, what happens now?
Behind the stopper. Like play, like yeah, I can move it and stuff. While I can.
Okay, so hit the pause button for me. No, hit the stop button. Just hit the stop button. Okay, click on your cube. Click on your cube. Okay, turn off use gravity. Turn off is kinematic. Now go back to your Fox. Go down to the rigid body on this one. You do not have a rigid body. Oh, you do have a rigid body. Turn off use gravity. All right, now hit play. So now it's still not going to work because you didn't hook up your audio sources, but go ahead and move it into the cube. Okay. Cool. So hit the play button or hit the stop button for me. So we still need to make sure that you've hooked up your audio clip and your audio source.
Which I. Yeah.
Okay, that's okay. Can you show me your script for a second?
Oh,
Cube
yeah.
script.
Oh, yeah, and also I just commented the audio thing.
That's fine.
Well,
Hit. Go ahead and no, it's fine. We can keep that. You want to get rid of the audio or comment the audio source until we're sort of there. Okay, save this. Let's go back to Unity real quick. Okay, so we should get a debug log if it's working. Hit play. And move you over to the right. No, nothing. Okay, hit the stop button. Click on your cube for me. Cube has a box collider, unsurprisingly. Cube has a rigid body, but it's non-kinematic. That's all fine. What version of Unity is this? Okay, so you should have the same version that I'm running. Hit Fox. Scroll down. You don't have a box collider on Fox. Hit Add Component. So you have no collider to tell it where the edges of the Fox are. And then go to Physics, go to Box Collider. That looks great. Hit play. One more again. And we will slowly move it into the apple or the box, and it will disappear. Okay, one last thing that I want to do, and then you'll get at least a 30-minute break before I will completely talk to you about a completely different topic. There's one other aspect of Unity that I want to introduce to you today. And that is the notion of prefabs or prefabricated objects. So right now what I did is I just duplicated the apple. That's a terrible idea, actually. I should never have done that. Somebody who went through and duplicated the apple a billion times would have all sorts of problems later on down the line. Because what happens if I say, oh, that apple object is actually pretty bad. That's just a sphere. That looks nothing like an apple. I want to replace that. If I did that and I had duplicated apple a whole bunch, I would then have to go through every single one of the duplicates and individually change them. That sounds like a nightmare, right? So instead of doing that, what we're going to do in Unity is we are going to, first of all, let's delete the other apple. I should never have duplicated. Why would I duplicate? What we're going to do is we're going to grab our apple, and we're going to do a click and drag of our apple back into our assets. Just like that. So what that functionally just did by grabbing the Apple object inside our sample scene and dragging it into the assets is that it saved our Apple to the disk. Remember, I kept on saying the project view is the thing that's basically the on-disk memory of the game, right? The saved stuff in the game. So we now have this saved Apple object. And in fact, I can look at it over here on the right in this sort of project view, and I can make changes to it in terms of the project view. So for example, what if I wanted a really tall apple, right? I could change that like that. And now that I've saved it, we can see that it's going to change that instance of the apple, right? And I can also click and drag it from the assets and put additional apples in this scene. And you'll note how they're all blue in that same way. That means that if I were to go through and say, why on earth did I make it a tall apple? That was such a silly thing to do. I should never have done that. I want to go back and I want to change that to a one-sized apple. They're all going to change. In this way, we can have a saved object that will behave in whatever way we specify, and we can duplicate as many of the times as we want, including with code, which we didn't get to today, which is where we would have gone to next, but we didn't get there. Such that we could have it such like spawning in upon a certain random timer, or et cetera, et cetera, et cetera. Cool? Okay. Cool. With that, you can stop concentrating for a bit. I believe there's coffee on the way or something. And take a few minutes, relax. If anybody has any questions for me or wants to figure out how to do something, feel free. If you want to keep on messing around with this, feel free. If you want a snack, feel free. If you need washroom, feel free. The next thing we're going to do is not in Unity at all. We're going to be doing a quick lecture on game design frameworks and then doing a paper prototyping activity. Thanks, everybody.